Alright, this is another Mrs. Weber's podcast, and today we're going to teach you about Lewis structures. And Lewis structures are kind of like Lewis dot structures, except you're combining them between elements. And they're going to share their electrons. So, the first step to doing a Lewis structure, we're going to do an example with H2O today. And the first thing you do is figure out how many valence electrons you have. And the first step is by filling out the chart is how you can figure it out. So in H2O, we have the elements H, which is hydrogen, and we have oxygen. And the number of molecules in H2O, well, H obviously has 2, and oxygen has 1. And then the number of valence electrons, this is where you would look at your periodic table, and you would see what group they were in. And hydrogen is in group 1, and oxygen is in group 6. And so what you do is you would multiply these, and so then you get 2 times 1 is obviously 2, and 1 times 6 equals 6. And then you would add these together, and you get 8. Alright, and then so 8 is how many electrons you have to do this structure. So then O would be the central atom, and then these, you would connect the 2 H's with a bond. And one of these lines equals 2 electrons. And one special thing about H's and Lewis structures is that they only need 2 electrons to be happy or stable. So these H's are already stable. And so you just finish it off and put the 4 remaining electrons around the central atom. Okay, so now we're going to do another example with carbon dioxide because we wanted to do an example that had double bonds and resonance structures. So we're going to start filling out the same chart to figure out how many valence electrons we need. So in CO2 we have the elements carbon and oxygen. And then carbon has only 1 molecule in it, and oxygen has 2, and carbon is in group number 4, and oxygen is in group 6. So we multiply these, and that 1 times 4 is 4, and 2 times 6 is 12, and then you add these and you get 16. So in this structure we're going to have 16 valence electrons available. So to just show you how, a single bond would work out, we're going to try it now. So we're going to put C in the middle and bond it to the 2 O's. And then we'll put, we'll put 4 more around the central atom. So that means we've already used 8 bonds, or 8 electrons, so we only have 8 electrons left. So 1, 2, 3, 4, 5, 6, 7, 8. And so this O on the side is not stable at all. So this way would not work out. And now we can try it with 1 double bond. So we'll do it to this O on this side. And we'll do a single bond over here. So that means we used 6 electrons. And so we'll only need 2 more electrons on here, because now C has 8. And then we'll put, and we've already used half, so we only have 8 left, and so we'll put 1, 2, 3, 4, 5, 6, 7, 8. And this still wouldn't work out because oxygen only has 6 electrons on this side. So that way wouldn't really work either. And now we're going to do it with 2 double bonds. So we're going to have a double bond to O, and then a double bond to oxygen. And C is already stable because it has 8 electrons already on it, because it has 4 bonds. And so we'll just put the remaining electrons on here. And that is how you do a double bond. But now there are also things called resonance structures, which basically mean there are different ways to arrange the electrons so that they're in a different structure. And in CO2, you can do this with a triple bond to O. Oh, here we go. And a single bond on the other side. And then we could also switch it around and do it the other way. And that's the resonance structures for CO2.